Today we are covering section 4.2, apply congruence and triangles. We are going to identify congruent figures. So, first warm-up question, when are two angles congruent? When they have the same measure. Two angles are congruent if they have the same measure. In triangle ABC, if the measure of angle A is 64 degrees and the measure of angle B is 71 degrees, what is the measure of angle C? Do we agree with 45 degrees? Pretty sure. They should add up to 180. So 60 and 40 would make 100. That'd make 9. Up to 80. 180. You unsure of this?
Yeah, because I got something different on the homework.
Definitely homework checking is a different angle.
Yeah, these are different.
Yeah, I don't think this is the same as your homework check.
It looks like it.
Okay.
It's pretty close.
Same type of problem, probably different numbers. It would be a huge coincidence if they happen to be the same exact numbers. All right, what's property of angle congruence is illustrated by the statement. Whoa, that is not even a property. Transitive property. The transitive property is the one where we kind of cut out the middle and go straight from what they started with to what they ended with. Questions about our warm-ups, other than whether or not number 2 was on your homework check? Okay. On we go. Into our notes. In two congruent figures, all the parts of one figure are congruent to the corresponding part of other figures. So all the parts have to match up and be congruent from one figure to the other if the two figures are going to be congruent to each other. The corresponding parts that we are talking about are the corresponding angles and corresponding sides. Note that every pair of congruent triangles has 6 pairs of congruent parts. 3 pairs of sides, 3 pairs of angles. Would you like to start with the sides or with the angles? Sides, okay, doesn't matter to me. Now they gave us what is called a congruence statement. This is called a congruence statement. And this actually gives us a whole lot of information. We don't even need the picture if we're given a congruence statement. So they line up corresponding parts from one triangle to the other when they make a congruent statement. And when you make congruent statements, you'll have to do the same thing. So if we are going to start off with our congruent sides, notice that DO comes first. So side DO or segment DO is going to be congruent to, good, CA. They have to match them up. Oop. CA. I don't really care if you call it CA or AC. It is the same thing. So knowing that they have to match things up for us, what's another pair of congruent sides?
And AG.
OG and a T. Notice that I'm putting the segment bar over these so that I am naming them correctly. If you don't put the segment bar over them, it is not correct.
Can you say D-O is congruent to AC? Which transit?
D-O and AC?
No, AP. Which transit?
D-O and AT? No, because we don't have anything connecting them. Does that make sense?
No.
Okay. Well, this one's CA and that one's OG. So they would have to be the same thing to like follow the path to get from one to the next. Does that make sense? Transitive property has something that's the same between them. And those are all completely different. Mattea? Very good. The last pair would be DG is congruent to CT. So the last one can be the trickiest. You kind of have to look at the first and last letter of both to get that. Next up are the angles. Again, make sure you're putting an angle symbol in front of it. Because this one only has one angle at each vertex, we can just use a single letter to name them. Makes it a little easier. Give me a pair of angles that you think should be congruent. A and O, sure. O and A. What else?
CD. C and D.
Angle G and angle T. The last one would be... Good, angle D and angle C. Now you could list these forwards or backwards. It doesn't really make a difference. I prefer to be consistent and start with the first triangle they list and end with the second triangle. That's just my preference. Now that we've made all these statements, we could mark the diagram to show this. It's not necessarily a requirement, but I could mark DO and CA congruent, OG and AT congruent. Same with our third pair of sides. And we could also go through and do all the angles. Notice that these are oriented a little differently from each other. So I'm just matching up what I said in my congruent statements and marking it in the triangle. Sometimes you'll be given just a congruent statement. Sometimes you'll be given just a pair of triangles. So just be familiar with all of these representations. Questions, concerns about this example? Are we all clear on the whole matching up or going in order from one statement to the next? That is critical. Okay. Moving on. Finish the congruent statement for the triangles. Identify all pairs of congruent corresponding parts. So once again, we'll have to have 3 pairs of sides and 3 pairs of angles. Give you a minute to work through this on your own. And then we'll go through and fill them in together. All right, when we finish the congruence statement, we better make sure that we are matching up corresponding congruent parts when we do that. Meaning that if letter A comes first, whatever angle is congruent to angle A better come first for our next one.
Yeah.
What's congruent to angle A? F. We might as well fill that in while we're at it. Next is B. Which angle is congruent to B? G. Again, can fill it in over here. And lastly, of course, is H, which is congruent to angle C. Last thing we have to do is fill in our congruent corresponding sides. Which side is congruent to AB? GF or FG. What about to BC? GH or HG. And to AC, FH. Questions, concerns about these? Need more time on this slide. Moving on. All right, in this one, they are telling us that triangle ABC is congruent to triangle FED, and we are asked to find the value of X and Y. It might be helpful for us to list out some of our congruent angles, or you could just look in the diagram and see that some of them are congruent. So for example, angle B is congruent to which angle? E. Okay, they're both in the middle, angle B, angle E. So if those two angles are congruent to each other, B, I should probably put like 3 tick marks on it, but B is congruent to E. What's an equation that I could set up? 2y minus 3 equals 129. Good. If those two angles are congruent, they should have the same measure. How would I solve this?
Add 2 divided by 3. Add 3 divided by 2.
Good. Add 3. 2y equals 132, and then we divide by 2. What do we get for y? 66. Wonderful. All right, what equation can we set up to find x?
Angle C is
Okay, it might be helpful to note that angle C is congruent to angle D. They even marked it in the diagram this time. So what equation would I set up from that? X over 2 plus 1 equals 31. To solve it, I would subtract 1 and then multiply by 2. Good. Times 2 to undo that division. X equals 60. Okay, and they just wanted us to find X and Y, so we can stop there. If they'd wanted us to find the actual angles, we would have to plug it back in. Questions, concerns, ready to move on? Ready to move on. On we go. The third angles theorem states that if two angles of one triangle are congruent to two angles of another triangle, then the other angles or the third angles are also congruent. I don't care if you call them the other angles or the third angles. If we were already talking about two pairs from each triangle, the third pair or third angles are also congruent. And that should make sense. We could prove that knowing the triangle sum theorem, that all three angles would have to add up to 180. Questions, concerns about the third angle theorem? Even though we can prove it, it should kind of just make sense. So, we are asked to find angle V, the measure of angle V, using the third angles theorem. So right now, we know that angle T is congruent to which other angle? Angle W. We also technically know another pair of congruent angles. Anybody know what angles are congruent? Or why? I'll give you a hint. The other pair we can't just say with one letter. Kara, what do you think?
TUS is congruent to WV.
Very good. Angle TUS is congruent to angle WUV. Does anybody know why? Somebody said it. They're vertical angles. Okay, so if they told us we had a congruent pair and we figured out another congruent pair, being those ones in the middle here, by the third angles theorem, which other angles have to be congruent? We can just use one letter on these ones. What is it? S and V. Angle S is congruent to angle V by the third angles theorem. So if we can figure out the measure of angle S, that'll be the same as the measure of angle V. Questions, concerns about this thought process? Okay, how could we find the measure of angle S?
These two equal to V. I mean W.
What do we think? Add what together? And after we do that, we would subtract it from 180. So if I add up all three angles inside, it should equal 180. So if I take 180 minus 66 minus 44, or if you'd rather add them together and then subtract one big number, that's fine. Either way, what do I get? 70. So if S has a measure of 70 degrees, so does angle V. Questions, concerns? Moving on. Here we go. I told you they were coming back soon. But I promise this one is not all that bad. We are given a whole lot of information for this one. Speaking of givens, what do I start with when I start a two-column proof? The givens. So I've got a lot of stuff to list out for this. FH is congruent to JH. I'm going to try to mark stuff as I go. I'm also told FG is congruent to JG. Marking that as well. We are told angle FHG is congruent to angle JHG. So that would be these two little ones up at the top. We are also told that angle FGH is congruent to angle JGH. So that would be the small ones at the bottom. How many statements are we missing to be able to say that the triangles are congruent to each other? 2 of them. Remember, we have to have 3 congruent pairs of sides, 3 congruent pairs of angles. So right now they gave us 2 sides and 2 angle statements. We need 1 more statement about sides, 1 more statement about angles. Which one do you want to do first? Because it really doesn't matter. Sides, sure. 2. This one is something that's going to come up over and over and over again when we do proofs. What is the third side of both triangles? Imagine that this was a piece of paper and I could cut the triangles apart. What's the third side of both triangles? HG. So side HG is congruent to side HG. It occurs in both triangles. Do we see that? If we were to cut it along the middle, H and G, it's the same thing on both triangles. What property allows me to state that a side is congruent to itself? Reflexive property. All these properties are coming back. The reflexive property allows me to say that something is congruent or equal to itself. So we're done with all of our side statements. You could mark that last side just with 3 tick marks to say it's congruent to itself if you want to. You don't have to. So the last thing we need is a statement about angles. Which 2 angles are left? F and J. Since there is only one angle at F and only one angle at J, it's fine to use just F and J. For our other statements, we couldn't use just G or just H because there were multiple angles occurring there. Anybody think they know why I can say that that third pair of angles is congruent? You sound so thrilled by it. But you are correct. It is the third angles theorem. We were told that 2 pairs were the same. So by the third angles theorem, the third pair of angles would also be congruent. Do we have enough to state our proof statement that the triangles are congruent? We sure do. So my last one is my proof statement. Triangle FGH is congruent to triangle JGH. Anybody think they know the reason for that? If you're whispering it, I can't hear you. Otherwise, it's just the voices in my head. Somebody said it. Or started to. Definition of congruent, not just angles.
Triangles.
You could say triangles. I would say congruent figures. Definition of congruent figures. If you put definition of congruent triangles, that would also be acceptable because these were triangles. That's fine. Questions, concerns? Warm, fuzzy feelings? Okay. Your homework should be on your sheet, but here it is on the board. I would expect a homework check tomorrow. Just heads up, FYI.